Some feedback on how to solve resistance in series and parallel from the 2011 exam. For any of these types of circuits, first of all, you've got to look closely at the circuit and redraw it so that you understand exactly where each resistor is in relation to the other resistors. For example, these two resistors C and D are just in series with each other in that arm of the parallel circuit. So you could redraw that with C over here and D just below it if that makes it more simple for you. So don't get confused by the placement of the diagrams. The next thing you have to do is work on each section of the circuit and break it down logically into sections of effective resistance. I would start with this arm here. You've got C and D, two resistors of 2 ohms each in series. So the total resistance of this arm of the circuit here is just 2 plus 2 ohms, which is 4 ohms. So really you've got a circuit where you've got a resistor here and an effective resistance in this other arm of the parallel circuit of 4 ohms. The next step after doing that, and you can redraw the circuit if you like with that effective resistance, then you need to look at this whole parallel part of the circuit. So you've got effectively 2 ohms in this arm and 4 ohms in this other arm. So you can use the formula 1 over R total equals 1 over R1 plus 1 over R2 to find out the effective resistance of this whole part of the circuit here. And then you can work out what the total resistance of all of these resistors in that configuration is. Once you've done that, you can redraw the circuit again if you like with a single resistor which represents the total resistance in this circuit, and you find that that resistance is 1.3 ohms. Finally, you've got two resistors just in series then, so you've got A, which is 2 ohms, and this whole section here which has an effective resistance of 1.3 ohms, which demonstrates that the total resistance of the circuit is 3.3 ohms. And if you lay that answer out clearly, that's how you get full marks for that exam question.